Hello and welcome to the common webinar with IBM today. My name is Dominik Schottenhamel and I'm sales representative for Germany, Austria and Switzerland for EnOcean. And yeah, I will switch off my camera to save bandwidth. Yeah, for all participants who are not familiar with EnOcean, I will say shortly a few words. We are a manufacturer of sustainable and battery-free solutions for building automation and smart offices, smart homes, smart places, market for 20 years. These kind of solutions are all based on the energy harvesting technology, what means generating energy for switches and sensors from the environment via kinetic, solar and temperature differences. And exactly that combination of energy converters, ultra low power electronics, and radio technology based on open standards like EnOcean, Bluetooth and Zigbee builds let's say the foundation for digitized buildings, services and production processes in the IoT market. And we have a strong partnership network with companies all over Europe who are using the EnOcean solutions. And yeah, in that context, I'm really happy to introduce our partner IBM for this webinar. Before I will hand over to Joseph McKay, I will make you aware, if you have any questions, feel free to write that in the question field, and we will answer on that after the presentation. So yeah, now I will hand over to Joseph, and yeah, enjoy the presentation.
Hello, thanks for all joining today. So a quick introduction on me. I'm Joe McKay, or Joey McKay, or Joseph McKay. I get called everything. I've been at IBM for 8 years now. I did 7 years in the UK and recently moved over here to Munich. Those years at IBM have all been in IoT, and almost all of them actually working in some way with EnOcean sensors in one form or the other with lots of the UK partners. Since coming to Munich, I've been working in the innovation studios, and actually here in the studio, we have quite a lot of EnOcean sensors. The room I'm currently sitting in, and the image on this screen is our EnOcean showroom. This room contains 35 EnOcean sensors. We also have our general office space, which has the under-desk motion sensors under every desk. And we also have some of these motion sensors in our office spaces. So we have quite a lot of sensors here. And in today's next 20-25 minutes, I'm going to talk to you about some of our use cases here and how we actually work with EnOcean to try and gain insights from this sensor data. So just a quick showcase here. As I mentioned, we're at the Innovation Studios here in Munich. These are some of the different dashboards we've actually made in relation to our EnOcean sensors. The first one is the comfort levels in the room Yanzi. That's the room I'm in. As I mentioned, it's got 35 sensors, but I'll talk about that in a moment. Below that, you can actually see a heat map. This is using the motion sensors to look at the hotspots in our center where people might be sitting to again gain insights. And the final image on the right-hand side of the screen, that is our room booking system, which again is using EnOcean sensors. So you can already see we've got quite a lot of different use cases here, and we can always talk about EnOcean and facilities management. So the first one I'm going to go a bit more in depth into, the EnOcean showroom. And I know my camera doesn't do justice to this room, so I actually have an image of what the room looks like. Here on the table, you see this light. That is a temperature and humidity sensor, and also a light sensor. On the wall, which is actually the sensor you may or may not see behind me, I don't know how good the camera is, that is the climate sensor with humidity, temperature, and CO2. Under all of these chairs here, we have the vibration and look sensors. And on the ceiling up here, you can see we have the motion sensors again. Now, as none of you can actually be here, I hope this picture was good enough. When we actually have people here in the innovation studios, we like to take them around these rooms to show them a bit more in depth what we have. So I spoke very briefly about this room. As I said, there are 35 sensors here in total. We have temperature, humidity, sound, lux, motion, CO2, and vibration. That's a lot of different sensors, and we don't use all of them for every showcase, but one of the big showcases we do actually use 5 of these types of sensors is for our room quality. When I mention room quality, I'm talking about the air quality. It's our first use case, and it's how we can use all of this sensor data to try and gain an understanding of how comfortable it is to be in this room at any one time. When we were discussing the idea of this room, we looked at these sensors and decided what would be the best to actually understand how comfortable this room was. Going off past use cases, which I'll talk a bit more about towards the end of this webinar, we decided that the best bits of data to look at were temperature, humidity, sound, lux, and CO2. Then we started talking about weightings we could actually give to these sensors. You know, how much does the temperature of the room actually impact how comfortable this room is, and how much does the humidity, sound, lux, and CO2? From this, we decided, well, the CO2 in the room probably has the biggest impact on how comfortable a room is. However, no one really knows how much CO2 is ever in a room. It's an invisible condition you don't really understand. So what else do people notice? Well, if you go into a room, you generally know if it's too cold or too hot. So we gave that quite a high rating. And also if the room's too humid. With the sound and light, we included these just to actually gain an understanding of how noisy the office actually was, and also how bright it was. Whilst these two don't have a direct impact on the comfort of the room, they were still quite interesting to understand. And as we use quite a lot of historical data, when we collect all this data, it's good to know, how loud we get throughout the day and if the rooms do get enough light. But the main 3 were temperature, humidity, and CO2. When we started looking at this, we started looking at some of the thresholds. And when I go back to the previous image, you can actually see the dashboard we created with our different ratings. You can see we actually put what would be optimal for these readings and what optimal range might be between. With temperature, we stuck between 20 and 24 degrees. This was a room that's not too warm, it's not too cold. It's a good condition. Same with humidity, we still kept around 30 to 50. With sound and light levels, again, we did give them optimum ranges, but these weren't really too important for the overall room. The big one I do mention, however, though, is the CO2. And this is a really important condition we like to talk about. As I mentioned, it's a bit of an invisible condition. No one ever knows what the CO2 is like in a room. And that was one of the bigger problems we had to come up with first. And you actually see this light sensor I mentioned previously here on this picture, or right here in the middle of the table. We thought, how can we use this in our EnOcean showroom? So we decided, okay, well, we already know it's on the same network as all the other sensors, and it's an EnOcean sensor, and it collects the data. Can we not change the light color based on the CO2 in the room? So that was the first thing we did. We started to look, okay, if CO2 is between a certain threshold, let's have the light be green. It's a good room. If it goes above this threshold, we can have it to orange. This could be a very simple warning to maybe you've had this meeting in the room a bit too long, maybe you should take a break. We then had a third variable. If it went above a certain threshold again, it would go to red as a really good indicator to you should definitely leave the room now. It's probably not very comfortable. And again, later on, I'll talk about actually what these thresholds are and what they mean. So the other things you can see on these images, a bit more of a close-up of one of the vibration and look sensors on the chairs, and the sensor behind me, which is a climate sensor. You can also see another interpretation of our dashboards. This is actually using part of our maximum application suite here in IBM to gather historical data and see the trends throughout the week. Just from a simple image here, you can actually see how much motion changes throughout the room. We actually have motion on 2 sides, as the sensors only cover half the room each. So we look at activity on the left side and activity on the right side of the room. And I say, I'm not going to go too much into why we collect these data until right at the end of the webinar. I'm just going to give you a brief overview of the room itself. When I talk more about the use cases in the future, I'll go more in depth in these. So the next thing I'm talking about, what we previously said, that was more on the facilities management and how we as IBM and EnOcean work together on that. But we don't just do facilities management. We actually use some EnOcean sensors to do Industry 4. In this case, we use a different type of temperature sensor, and we also use some electric current sensors to monitor an electric motor. We could also use some of the vibration sensors, but we use different ones in this case. But with these same technology used in EnOcean, we're able to actually put these onto an electric motor and start gathering this data and looking at the health of this motor, how it actually changed over time. Now, we would turn the motor on, we'd see how long it actually took to go from its non-operating temperature of around 27 degrees to its operating inefficiently, which was about 50 degrees. And then we also included the electric current. And we could start to see how current and temperature relate to each other. As you would imagine, as the motor was turned on, the current obviously increased. As you ran it faster, the current also increased. And one of the first ratios we actually noticed was when the temperature was higher, the current was lower. From this, we actually gathered that it was a very inefficient motor, and at the lower temperatures, it would overheat. And this was just from 2 of the EnOcean sensors. So we can very quickly actually see, not just with EnOcean are we doing facilities management, we can also do Industry 4. And here in the Innovation Studios, we actually link both these use cases when we talk about the EnOcean showroom and this electric motor, which talk about how these can be related. In this case, this electric motor could actually be the air conditioning in the room. It could be the fans that actually help circulate the air quality. And if this motor were to start having anomalies or faults, or even just slow down, that might actually have a huge effect on the room itself. So again, we're showing how we can link a showroom and an Industry 4 asset into one big demo and talk about these a lot more in detail. Now for the bulkier part. This is kind of what it looks like from IBM's side of things. We have our devices and we have our data ingestion. The partners we currently work with EnOcean actually already have IBM's IoT platform as part of the gateway. So all we have to do is connect the sensors to the gateway, and once they're on the gateway, we can very quickly get this data to our cloud. Once it's on our cloud, we work with a lot of the data manipulation, some of the dashboarding, and also sending it further on to some of our assets like Maximo and Chariga. And here on this architecture page, you can kind of see how that all goes together. So I've been beating around the bush this whole time, not saying many thresholds, not really saying why we're collecting data, just that we are, and that the reason we're collecting it, is to look at rooms. What I'm going to talk about now is actually what we've already done as a POC in London. And it's very similar to what's in this room I'm in right now. So I can't mention the customer, but I will mention that it was a facilities management company in London. And this company actually wanted to use this solution to send to their customers. So it was a really good use case. We actually started this use case in their own facilities. And then after that, they could reference this use case with their customers. So exactly the same as I mentioned here, we used EnOcean sensors. We put temperature sensors around, humidity sensors, CO2 sensors, started collecting all of this data. We also had the motion sensors, again, under the desks and in the meeting rooms. We then started talking about what is the reason, why is this important? What can you actually gain out of this? And this company was telling us that they actually have a very low employee retention in their company. And when they were doing exit surveys with their employees generally would say there was nothing wrong with the job. They just didn't like the office environment. So then we came in and asked, okay, how can we actually help this office environment to be a bit more comfortable? And so we put these sensors around and actually found, okay, on this side of the office, it's really warm and humid. And on this side of the office, it's not. And it turned out a lot more employees worked on one side than the other. That was a good start. So maybe, were these employees leaving because the room quality wasn't what they expected? We then started talking to them about their end of quarter meetings, and they would tell us, okay, yes, and this is before COVID, of course, At the end of a quarter, they would have a meeting room with 6 or 7 people, occupancy, but they would have 10, 12 people in this room for 8-hour-long shifts. And this was a standard practice. Lots of companies were doing this. In London, in England, in fact, we really don't do much in air conditioning. So a lot of our rooms have very poor circulation and ventilation throughout the day. So you've got to imagine, these small meeting rooms that should only have maybe 8 or 9 people, suddenly having 12 people in this room for 8-hour long. You've got to imagine the temperature rise in this room, and it's starting to get really uncomfortable. But this is when I go back to CO2, the invisible thing that no one notices. So CO2, for some interesting statistics here, a general office space is between 400 and 800 parts per million of CO2. At these levels, CO2 is fine. There's no adverse effects. You sit in this room, you're not going to notice it. Now, once CO2 starts to rise and it gets above 1,500 or 1,500 parts per million, people start to feel a bit drowsy. So the workload people can actually do, the productivity starts to go down. Further, if the CO2 gets above 2,000 parts per million, that's when some people start to get headaches. And these are things that you kind of learn when you're working with CO2 a lot, but the average person, the average employee in an office space, they never think about these conditions. And they work in these offices all the time and just kind of live with it. It's not something people know. So doing the same thing we did here in this EnOcean showroom, we put the CO2 sensors in, temperature, humidity, started looking at the office space, and instantly we found, within 2 hours of people being in these rooms, the CO2 was starting to rise, as expected. And the CO2 was starting to get above these first thresholds of 1,500. Now, doing some surveys online, you can actually find out a lot more about the bigger impact of CO2. And it's estimated that a high CO2 workplace actually loses about 20% to 30% productivity when the CO2 starts to get too high. So just looking at productivity, forgetting the employee retention for a second, if you're in a meeting room for 8 hours and you're losing 20% of your productivity, that's a lot of work lost. And if you've then got 12 employees losing all that productivity, you're starting to lose half a week's worth of productivity because people are in this room for no reason for too long. And that's the first thing we started doing. We moved away from the employee retention and just went, actually, doing this POC with you, we found a huge reason of loss of productivity in the office. So we sent that to them, and they thought that was brilliant. It wasn't what we actually came in to do with them, but it was an insight they actually learned just from a simple POC that took hours to install. We then went back to the employee retention and started looking at all these conditions, and actually, to start with, we did a placebo and put a thermostat in the office that the employees were actually able to alter, even though it changed their temperatures. There was then a survey, and employees said they were happier with the temperature. So just by thinking they had more control over the temperature and seeing what their ideal temperature was, which was a couple of degrees lower than the office actually was, we then started to change the temperature ourselves, and employees were happier. Whilst this POC was running over the course of about 4 months, there wasn't too much of a change in the employee retention, but we did have surveys with these employees, and they were all coming back saying they were much happier with the environment they were working in. And this POC was done, it was over the course of 3 months, but the actual installation was over the course of a few days. So it was very quick to do. Getting the actual data to the cloud, as I already mentioned, it was already built into the gateways. We then put it on our system of Maximo, started gathering the data, looking at data over time, and just gained all this insight that they never had before. Instantly, they were finding out loads about their company they didn't know. They were making different areas of the office more comfortable. Then they were seeing people would sit in different areas of the office. Before, they don't sit on the left side. Now they sit on the left and right because the whole office conditions were far better. And that was, again, very simple to do. And it's what we try and talk about when we have people here in our innovation studios in this room I'm sitting in a very similar way. And now I think I talked rather fast today, and I think we're already up to the Q&A, and I think I might have gone quite quick, but I've got to ask any questions.
Yeah, thank you, Joseph, for that really, really interesting presentation. Yeah, in the meantime, we received a lot of questions, and yeah, I'm pretty sure Joseph is really happy to answer on them. So the first one, how long should a room really stay at the maximum occupancy?
So that one is really interesting question, and it, to an extent, country dependent. For example, in Denmark, CO2 actually is not allowed to be above 800 parts per million, and it has to go below that or the company can get fined. So when we talk about something like that, if you've got an 8-person occupancy room with 8 people, again, it obviously depends on age, gender, but for the most part, after about 2 hours, CO2 will go above this threshold. So if you're talking a small room, usually between 1 and 2 hours is a good amount of time to keep a room occupied. Otherwise, the CO2 will really start to go high and effects will start to occur.
Okay, thank you. Another one, how much effort is required to create something similar?
Fantastic. So starting with the room I'm sitting in, you can put 35 sensors in this room in an hour and you can get it to the cloud another hour later. A big office floor, like the use case I was talking about, that had, I think, close to 200 sensors and took 1 or 2 days to install all these sensors and get them up and running. There's another use case IBM did with about 1,000 sensors, and that took a week. So it varies, but if you're talking, one standard office floor with maybe, I don't know, 100 desks, you could probably do that in a couple of days.
Okay, thank you. Yeah, this one is good. How can I help to improve the working environment for people?
So the simplest one is regular breaks, and that should be maybe that's kind of the reasoning for, in this room I'm sat in, the light. The light, when it changes color, is an indicator that maybe we should take a 10-minute break. Again, I'd say it's very location dependent. Here in Munich, if we open the windows in this room to make the air nicer, there's no problem with that. We're next to the English Garden, it's beautiful. In London, very different. If you open the windows in London, you're probably making the air condition worse. So usually it's regular breaks. Obviously, rooms with a bigger occupancy with less people actually in there at a time is preferred.
Okay, thank you. Yeah, I would suggest we answer on one further question, and the rest of the remaining question we will answer on by email after that presentation. So a last one, what does CO2 have to do with productivity?
Yeah, so I say online you can find lots of information about CO2, but the biggest one being, once it gets above 1,500 parts per million, and if people are in a room with it above 1,500 parts per million for about 2 hours, they estimate between 20% to 30% loss of productivity. And this is generally because people are feeling a lot more drowsy. If the CO2 goes above 2,000, that's the headaches. And again, that can lead to a large amount of productivity loss.
Okay, thank you. So yeah, then I would say we will close this webinar. Thank you all for the participation. I hope it was interesting for you. For me, it was definitely, and yeah, we would both be happy to receive some more questions via email. And yeah, I'm happy to hear from you again, and thank you for participation and have a good day.